All right, so at the end of this section, we're going to see applications of quadratic equations, and these sound super scary when you first read them. So when you first read them, they're going to sound super intimidating, but I'm going to let you guys in on a little secret. You'll start to see a pattern. Vertex, vertex, vertex. These questions are all about finding the vertex. They're all about finding the vertex. So I want you guys to remember that for a vertex, your x value will equal negative b over 2a, and then you will find the y value from plugging in that x value. Okay, then find y. Okay, so looking at number 8, a person standing close to the edge on the top of a 160-foot building throws a baseball vertically upward. The quadratic function below models the ball's height above the ground, s of t, in feet, t seconds after it was thrown. So s of t gives us the feet above the ground, t seconds after it was thrown. And notice that we're used to seeing f of x equals, so t is acting like x usually does. So it's acting as our input variable. So I just want to point that out. So up here where I wrote x equals negative b over 2a, now we can think of it as t equals negative b over 2a because that's our input variable in this function. So we have the function s of t equals negative 16t squared plus 64t plus 160. So our coefficients, a is negative 16, b is 64, and c is 160. Now part A says, after how many seconds does the ball reach its maximum height? Its maximum height. All right, so imagine, before we answer that, imagine that we graphed this function. We could, of course, graph it in our graphing calculators, but imagine if we graphed this function. What would it look like? Well, it's quadratic. Highest power is 2. I know it's going to create the shape of a parabola. It's going to be a downward facing parabola, right? Because a equals negative 16. So when I go to graph it, it's going to have that downward facing parabola shape. So the vertex represents a maximum point on my parabola, right? The vertex represents the maximum. So they said after how many seconds, okay, so that's really what we're trying to find here. After how many seconds does the ball reach its maximum height? The vertex is our maximum point on this graph. So we're going to be able to answer this just by finding the vertex of that given function. Okay, so let's find the vertex of s of t. So first, instead of x, we're going to find our t value. T equals negative b over 2a, which in this case is negative 64 over 2 times negative 16. 2 negatives will give me a positive result. 64 divided by 32 gives me positive 2. So t equals positive 2. Remember that t is our number of seconds, and that's what a is asking us for, right? So when we find t equals 2, the ball will reach its maximum height after 2 seconds based on this function. Okay, so we found our t value. Now we want to find s of t, s of 2 in this case. And we can go ahead and type this into our graphing calculator. Negative 16 times 2 squared plus 64 times 2. Oops, that's a 5, not a 2. There we go, 64 times 2 plus 160 gives me 224. So when we get to B and they say, what is the maximum height of the baseball? Remember that that's what S of t is telling us. It's telling us the feet after a certain amount of seconds have elapsed. So after 2 seconds, when we're at the maximum height of the baseball is going to be 224 feet. Okay, so this problem sounded really scary, really intimidating. If we calculate the vertex, we can answer it, right? So we're just calculating the vertex there. All right, number 9, you have 200 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence the side along the river, find the length and width of the plot that will maximize the area, and what is the largest area that can be enclosed. All right, so here's our river, so there's no fence over here. There's no fence over here. Okay, and let's say, it doesn't matter what you label what, but let's say that maybe this is the width going across, and this is the length of our plot. Okay, so based on the way that I labeled it, and I'm using L's and W's, you could use, different variables if you'd like to, but based on the way that I'm labeling this, we know that we have 200 feet of fencing, so 2 lengths plus just 1 width, right? We're not fencing on this side because there's a river. So 2 lengths plus 1 width equals my 200 feet of fence. Okay. And notice that right now I have 2 variables, so that's not ideal. I could solve for W and get W equals 200 minus 2L. So W equals 200 minus 2L. Okay, so that's going to come in handy in just a minute. This problem is asking me to find the length and the width of the plot that will maximize the area. So what's the area of this rectangular plot? We know A equals length times width, right? L times W for a rectangle. And in this case, I can say this equals length times, and now I'm going to replace W with 200 minus 2L. 200 minus 2L, 200 minus 2 times the length. Okay? So now this is our area. And if I distribute, A equals 200 times L minus 2L squared. Or I could rewrite this as A equals negative 2L squared plus 200L, just writing these in descending power order. All right, so I want to maximize this area. I want to maximize this area. If I were to graph this area, notice that I'm looking at a parabola, right? I'm looking at a quadratic function. Highest power is 2. I have L squared. If I were to graph this, it'd be a downward facing parabola because A is negative 2 less than 0. If I want to maximize the area, I can answer this by finding the vertex. The vertex is going to be the maximum point on this graph. The vertex represents the maximum area. All right, so notice for this function, A equals negative 2L squared plus 200L. L is acting like X usually does. So L is acting as our input variable. So usually we say X equals negative B over 2A. Now I'm going to say L equals negative B over 2A. And for this function, we have A equals negative 2, B equals 200, and then there's no constant term, so C actually equals 0. So for negative B over 2A, we have negative 200 over 2 times negative 2. The two negatives will cancel each other out. 200 divided by 4 gives me 50. And remember that L represents the length, so that means that we have a length equal to, and we're using feet, right? So length equals 50 feet. So length 50 feet, length 50 feet. All right. The width equals 200 minus 2 times the length, so that's going to be 200 minus 2 times 50. 2 times 50 is 100. 200 minus 100 gives me 100 feet for the width. So width equals 100 feet. All right, so there's the length and width of the plot that will maximize the area. Part B says, what is that largest area? We know the area equals length times width. The length is 50 feet. The width is 100 feet. And if I multiply these, 50 times 100 gives me 5,000 in my calculator. Feet times feet is feet squared or square feet. So I have an area of 5,000 feet squared as the largest area that can be enclosed. So word problems, vertex. You'll see these word problems will consistently ask you to maximize something, what's the minimum, and that's your tip-off that you're finding the vertex because that represents your minimum or maximum of your quadratic function.